So, let us see few questions on the linked list. I hope the first question is visible. I will read it for you, and let us try to analyze what is the answer for this question given. Let SLLDEL be a function. It is a function. Single linked list delete is a function that deletes a node in a single linked list, given a pointer to the node and a pointer to the head of the list. Okay. So, you have a single linked list, you are deleting a node. If this is a list like this, okay. So, given a pointer to the node, this node, suppose I want to delete this node. So, let this be temporary pointer t which I want to delete, and pointer to the head of the list. By default there should be head of the list. Similarly, DLL del means double linked list delete be another function that deletes a node in a double linked list given a pointer to the node and pointer to the head. So, again in the same way we have a double linked list with us in both directions. So, it is this way, right. So, again double linked list will have 3 options like this. Okay. So, this will be null, and this is my head, and this is the node which I want to delete, that is my temporary pointer. Now, the question is, so there are 2 functions, single linked list delete and double linked list delete. Let n be the number of nodes in each of this linked list. Which of the following choices is true about worst case time complexity of these 2 functions? So, before we go and understand worst case time complexity, let us understand how much time does it takes to delete a node. Okay. And in the beginning, in the end, at any given position. Generally, the worst case means deleting a node at the end of the list. Deleting a node at the end of the list. So, how do you delete a node at the end of the list? In single linked list, suppose I am deleting this node, the last node, or even last but one node, right. So, your while loop or your for loop will traverse till the end. It has to traverse till the end. So, if there are n nodes in that, if there are n nodes, I have to traverse through every node. So, I have to visit this, if it is null, no, visit this, if this is null, no, visit this, if this is null, no, visit this, if this is null, yes, stop here. That way, you have to iterate over the entire list till the end. So, your for loop is being applied on each of all the elements of the list. So, there we can say that one for loop is required to reach the end of this list. Therefore, I would say the single linked list deletion, the worst case could be order of n. Why order of n? Because there is only one while or for loop which is iterating over the entire list. So, we would say order of n is the time complexity. Now, what is for double linked list? Okay, in double linked list you are having 2 pointers next and previous. Okay, so here the double linked list deletion, again this is suppose I am deleting the last node, even though there are 1000 elements in the double linked list or in single linked list, we have to do traversing, right. But what is the advantage of double linked list? We say we can go front and also come back, we can go forward and also come back. So, to delete a node at the end of the double linked list, again there are 2 cases which is not clear here. If there is a tail pointer, if there is a pointer t, okay, if there is a pointer t which you already know, right, then it is just order of 1 because I have to just delete this element. But if I do not know this pointer, but if I do not have a pointer like this, then I have to traverse it and delete it. See, it is given as given a pointer to the node and pointer to the head of the list, right. So, this particular node, if you know to delete, you have to, how much time it will take? It will take 1 only. Here I have to traverse till the end, I have to traverse definitely. Okay, I will repeat once again. So, the answer will be option D. Why it is order of n in single linked list, why it is order of 1 in double linked list, let us see. I will talk about single linked list first. So, there is a list like this, it is null, this is my head pointer, and it is given in the question that I know the pointer, I know the pointer t. When I know that I am deleting this pointer, I should know its previous node, right? I should know its previous node. Only with that I can do some, why I should know its previous node. When I want to delete the last node where there is a pointer t to me, I should know its previous node. Why? Because I should make the previous nodes, let it be q. That q's next I should make it null to break this chain. To break this chain, I should know the q pointer. How do I reach q? Before t. So you need an extra logic here. You should know that before node also. For that you have to traverse the entire list. That's why it is order of n. Though the pointer t is given which points to the last node, with this I cannot do any operation. Why? With this t I need one extra pointer here. Only with t I cannot do the operation, because t is pointing to the last node. This is what I have to delete. But how do I delete it? I have to make this previous node, this next pointer to be null. To make it null, I have to reach here. For that I have to traverse the entire list. So I have to run a for loop or a loop I have to run. So looping means it will take order of n time complexity. This is the case. So that's why this SLL function will take order of n. Now the second case, that is double linked list delete. What is that? Let us see. So in double linked list, I will be having 2 pointers like this. So I will just quickly draw it. This becomes our head. Okay, so head is given, temp is given. Now with this it is very easy to delete. Why? It is just one step, one activity only. If you know the pointer t, if it is pointing to the last node, then temps previous, this one. Okay, temps previous, you will make it null. You will point it to null. It means this box will become null. That's it. When this is temps previous should point to null means this line will be broken. Temps previous it should point to null. So this chain will be broken here, right? So you are putting here null directly. How do you know this node? Because I know this node because there is a link here. If I know this node, I will know its previous node also, right? That's why it is just one step activity. I need not iterate and again reach here. With this temp t only, I can know its previous. Okay, you can put to temps previous next, temps previous its next equal to null. So this, the first line is broken. This connection, the initial connection will be broken. Okay, so that way you can break the chain here. You need not need any extra pointer. So that's why the time complexity for deleting a node at the end, or the worst case means deleting at the end only, is order of 1, and this is order of n. So this is the answer for this. Again, this is a previous gate question. Okay, let's move to the next question. Yes, again in a sorted double linked list. Okay, n items are stored in a sorted double linked list. For a delete operation, a pointer is provided to record to be to the record to be deleted. Same like previous case. In a double linked list, let us take some elements like this. Right. So this is my head pointer, and there are some connections. This is null, this is null, right? For a delete operation, a pointer is provided to the record to be deleted. For a decrease key operation, a pointer is provided to the record on which the operation is to be performed. Okay, an algorithm performs the following operations on the list. So to delete, it will take theta of n. To insert, it will take order of log n. Okay, to delete a node, it will take theta of n. To insert, it will take order of log n. To find, it will take order of log n. And decrease key is one function, it will take theta of n, right? So what is the time complexity of all these operations put together? Okay, see, you have to insert, you have to delete, you have to find, and you have to decrease. So again, it's nothing much to do with the linked list concept. It is a generalization. It is a generalization of these what you say, asymptotic analysis, complexity analysis. We have studied about different asymptotic notations like theta, omega, right? Using that logic, you can tell what is the generalization. What is the time complexity for all these operations put together. If you are doing all of them in together, what is the case, right? So when do we represent it as theta n? Again, little go back into the asymptotic notations, right? Order of this is for no theta, omega, and theta. If you remember, this is for generally best case. I said this is for worst case, and this is for average case. We generally use those representations. So this is the worst case analysis. If you have maybe that function order of growth, these are the order of growths of two functions, right? Theta n, that is the worst case. So if you generalize that, you can guess from this. Definitely not order of log n, because n is the highest one here. So I cannot take order of log n, right? And not even n square log n. Why? Because we have only functions with n and n. Okay. Now among these two it can be there. So even if I club all these things, it will only become order of n log n. Okay, more of a kind of asymptotic analysis kind of question. If you do all these operations together, again you are kind of generalizing the order of growth, trying to find out the order of growth. That's why it will say answer as order of n log n. Why? Even if you combine this operation, this is taking theta of n log n, this is taking log n, this is theta of n. All together it will take theta of n log n. Why? N means it will become n, log n it will become log n. So it comes as order of n log n. Next, a very recent question what we are having here. So I would request you all to please solve this. Consider double linked list with the following operations: insert first 10, then insert last 32, a equal to remove first, then insert last, then I am doing remove first and remove last 2 times. What is the value of this? What is the value of a after these operations? A is missing here. So what is the value of a after these operations? Recent data analytics, I hope you are aware of this. In GATE, we previously used to have only CS paper. Now we have got data science and AI paper, DA. So in this also there is the concept of data structure subject is there in this also. So can you guess what is the answer of this? Perform these operations and tell what is the value of a at the end after performing the operations. What is the value of a? Insert first. So insert first means inserting at the beginning. This is double linked list at the beginning. Insert last means at the end. So insert first means 10 comes here. Then 32 comes. Then a equal to remove first. So in a memory will be remove first means 10 will be removed. So 10 comes here. Then the list becomes only 32. This is gone now. Only 32. Now insert last. So again I am inserting elements, that is 28. Again insert last, that is 17. That is 17. So I got 32, 28, 17 in the list. Now a equal to remove first. 32 will be gone. So a becomes 32 now. Now a becomes remove last. Remove last means I have to remove 17, that is pasted into a. So after these operations, what is the value of a? It is 17. It is as simple as that. Very, very simple and easy question. This is a very new GATE paper. So I hope it is clear why the answer is 17. Right? Remove last, insert last. So it will add 28, then it will add 17. So I am updating the a value, we will get the answer as 17. Okay? This is a very new paper. It has been launched in 2024 only for the first time. So this year also, if you know, maybe next year you can write this course also. Let us see the next question. Okay, there is one function, code snippet is given. They are asking us what this code snippet will do. Okay, what this code will do. Let us try to analyze. Again, this you can see the question years are written here. So I am giving, there is a function f x1. I am giving head as the end. If head is null, return nothing. Otherwise, head next. Otherwise, head next. Right. So it is kind of a recursion. No, we are using recursion here. And what I am doing, I am printing head of data. So how does this happens? Okay, I am printing head of data. See, I am giving head. So let us assume again I will take a single linked list only, which is easy for us to calculate. right. So, I have a list like this. Okay. So, there are elements 10, 20, 30 and 40, and this is null. Now, this is my head pointer. This is given as the input. Recursion means I have to use stack, right? I have to use stack. Recursion uses stack. Again, that is known to us, but we are yet to study stacks. So, assume it happens like this recursion. So, head is passed. Is the head null? Null? No. Then it will come here. Head of next. Head of next means this one, right? So, in this case, when I am giving head will be here, then will come head of next. That is indirectly this is 10 and then 20 will come. Again, when I go, I am checking, is it is next? No, then again head equal head next. It means instead of this I am putting head next. So, it will come here. So, here 30 is inserted. Again it will go. Is it null? No. Then again go to next. So, head next. So, this time it will come to 40. Again it will go head next. After this, do we have anything? No, it is null. When it is null, it will return. So, it will come here. Then there is a printf function. Then there is a printf statement. Print head of data. When I am printing it, it will print in this order only. It will take 4 first, then that is it will print 40, then 30, then 20, then 10, because recursion uses stacks data structure. So, in stack it is like filling one on top of each other, right. So, when I print this the head of data, where is my head here? Head is here this time. Head is at this location. Why head is here? Because I am always passing head next, I am calling the same function. So, it will store all those pointers in a head. So, head is at 40 now. So, head of data. Next again, since it is recursion, it will keep doing reverse process again. So, it will print answer 40, 30, 20 and 10. So, from this discussion, if you see, it will print all the nodes of linked list. Yes, it is printing, but no, it will print all the nodes of linked list in reverse order, right. It will print alternate nodes, no. It will print alternate nodes in reverse, no. So, answer is it will print the linked list elements in reverse order, because recursion uses stack. For every function call, the output will be stored inside the stack, and once the recursion in loop is over, it will keep removing the elements from the bucket like this, one after the other. Okay. So, for this the answer is it will print the nodes of the linked list in reverse order. Next, okay, one more interesting question. It's again ISRO scientist post previous question that we are least bothered about. Let's focus on the problem. So, a double linked list structure is given. This we already know. Double linked list has 3 parts. One is the data part. What is the value part given according to this, and the other one is forward part. Other one is backward part. Okay, this is basic structure definition, where forward and backward represent forward and backward link of the adjacent elements that we know already. Which of the following segment of code, okay, deletes the node pointed to by x from the double linked list, if it is assumed that x points to neither the first nor the last node of the list. Okay. The question here is, they are saying that which of among these 4 options here, which of the following segment of code deletes the node pointed by x from the double linked list, if it is assumed that x points to neither the first nor the last. It means the question is simple. Here there is a list, double linked list is there. Okay. There is some node x which you want to delete. Let us assume this is the node. He is telling delete node x. Which among these 4 will delete the node x in a double linked list, and the condition is that x is not the first one nor the last one, because the deletion logic of deleting a node at the end and beginning is different. That is the reason he is telling, if you want to delete any of the elements in a double linked list in between, not the first one, not the last one, remaining all. So, which code will help us in deleting the elements? So, among these 4 options, which logic will help in deleting? So, it is same as your deleting an element at a given position. Deleting an element at a given position. Okay. So, assume that the best way to answer this question is that assume you have only 3 nodes. Assume you have only 3 nodes like this. Okay, so these links are there. This is my x. I want to delete x. There is a first node, there is a last node. Okay, let us see first option. X backward forward. X, its backward means this one. Let me put numbers so that it is very easy for us to understand. X means 20, x is 20, x backward is 10, x backward its forward is, see, x backward its forward. So, it is 10, its forward. This forward is nothing but x forward. What is x forward? 30. So, it is simple breaking this chain and including this one. Okay, x backward, that is 20's backward is 10, its forward, this pointer, I am pointing to x forward, x is here, its forward is 30. So, this node is pointing to 30. Then x forward backward, x its forward means this one 30, x forward is 30, its backward means this link, this chain, okay, is equal to x backward. So, this chain also I am breaking here and I am putting like this. Okay. So, that is the code which this A option is doing, right. So, it is true because we are breaking this chain, and this links are also deleted. Again, though we did not give, but actually it is linking these two. When I am linking this to this and this to this, means this is gone from the picture. Okay. So, this first option is satisfying. Maybe we will check if there are any other logic here. Anyhow, dot I cannot use, this is gone. Here also dot is there, this is gone. Let us see the fourth option. Because we do not use dot operator, we use arrow operator to deal that. X backward, x that is 20 is backward, its forward is x backward. No. See, it is pointing to the same element. X is pointing to 20, x backward is pointing to 10, x backward its forward is equal to x backward. So, this is 10 is again pointing to 10, that kind of relation is this. So, this is also not true. So, the answer for this is the first option. This logic will try to delete a node x from a double linked list. Okay. I hope you all are understanding this. I hope you are on track and understanding these things. So, let us see one more question. Okay. Given a single linked list, consider a single linked list of the form in this form where f is a pointer to the first element, f is given, and L is the pointer to the last element. So, in a single linked list, f and L are given. Okay. The time of which of the following operations depends on the length of the list. Okay. Now, to perform these which among these 4 operations requires to know the length of the list. Okay. Which among these requires to know the length of the list. So, let us see what is this answer for this. See, first operation, delete the last element of the list. If I want to delete the last element of the list, we know in single linked list we have to traverse the entire list, reach the last node. I should know this node, I should know its next node also. So, I am entire length of the list I am traversing. Okay. So, this again, this is the option for that. One option we got, that is because to delete the last node, last element, I have to traverse the entire length of the list, right. So, the time of that operation depends on the length. If the length is very small, if the length is, this list is very small, the time taken is very small. So, he is asking the time of which of the following depends on the length of the list. Okay. See the other operations here. Delete the first element of the list. It is just a one step activity, order of one time complexity. I need not iterate anything. So, whether the list is of 1000 nodes or 10 nodes, deleting the first element time is constant. Okay. Next, add an element after the last element of the list. Add an element after the last element of the list. Now, for which what is the time to add an element at the last? So, here L is my last node. After this, if I want to add, I already have this L pointer. I have just formed this connection, that is it. Okay. Whatever is the length, let there be 1000 elements, 10 elements. I already have in the question it is given clearly, there is a L pointer. If I want to add a list like this, it is again order of 1 complexity, because it is just creating this link, that is it. How do you create? You already have a pointer L. So, it will again, it has no significance with the length of the list. It has nothing to do with the length of the list. Okay. So, till now we found out that option 1 is matching, because to delete last element of the list, I have to find out last but one element. For that, if length is 10 elements, it will take some little time. If there are 1000 elements, it will take more time. Then interchange first two elements of the list. Interchange first two elements of the list. So, when it is clearly says first two elements, whether it is 1000 or 10, just I have to interchange the data of first two elements, fixed. So, again it is one time activity, I need not iterate anything, let there be 1000 elements later. Okay. So, therefore, we can conclude that the answer for this is delete the last element of the list. Delete the last element of the list, depends on the length. It depends on the length of the list. The time taken depends on the length. If the number of elements are 5, very less time. If the number of elements is 5000, more time. This is the question. Next. In a double linked list, the number of pointers affected for an insertion operation will be. Okay. So, you please try this and tell the answer. In a double linked list, number of pointers affected for an insertion operation. He has not given for which insertion. Is it inserting at the beginning, insert at the end, or insert at the any location? So, what could be your answer? In a double linked list, number of pointers affected for an insertion operation. Number of pointers means again this case, if we have a double linked list. So, suppose you are inserting an element here in the second location. So, this there will be already a chain like this, which I have to break. So, one pointer, right, pointer 1, this I am changing, then this pointer I am bringing here, then this back, again it's back. So, we are changing 4 pointers in double linked list. Generally, if it is at any position, okay, inserting at the end means again only 2 pointers, this to that, that to next. And for beginning at the front also means 2 pointers only, this to this and this to this. So, since nothing is given, it depends on the nodes of the double linked list. Answer is not 4, not 1, not 0. Why? Because it is not given where should I insert. Because inserting an element in a double linked list at the beginning and at the end takes 2 pointers, whereas inserting an element at any given location takes 4 pointers. Okay. That is why no, we can say it depends on the nodes of the double linked list. Okay. Right. Right. So, which of the following operations is performed more effectively by double linked list than the linear linked list? Which one is performed more efficiently by double linked list than in linear linked list? So, please see the options here. Deleting a node whose location was given, that is first thing. Searching an unsorted list for a given item. Okay. So, if I perform this, let us see first option, deleting a node whose location is given, right. So, in a double linked list, we have, I think we are repeatedly seeing this question of deletion. In a single linked list, if I want to delete this node and some pointer p is given, right, how much time does it take to delete this node? I have to traverse the entire list and reach its but one node, only then I can delete. Whereas in double linked list, if this node is given already, it is just breaking this link. I know a previous pointer. So, it will take very less time in double linked list compared to single linked list, right. So, deleting a node whose location is given is more efficiently done in double linked list. I think it is a kind of repetition of a question we have seen here. This one, right, same this first question, deleting a node in single linked list, I have to, even though pointer is given, I have to reach. So, answer is order of n for single linked list, whereas for double linked list it is order of 1 only. It is very easy to delete because you know the temporary pointer, its previous itself you have to make it null. So, it is almost same kind of a question here what we are seeing. So, deleting a node whose location is given is easy in double linked list compared to single linked list. We will also explore the other options. searching an unsorted list. Okay, in double linked list or single linked list, there is an unsorted list for a given item. Searching is same. Searching is common because you have to always traverse the entire list. If you are searching for an element which is at the last but one location, whether it is single linked list or double linked list, you have to traverse from the beginning only. So time is same for this here. So this cannot be answered. Inserting a node after the node with a given location. So again, whether it is single or double linked list, inserting a node is just single, time taken is almost same here also. Why? Inserting a node after the node with a given location. So this node in a single linked list, this node n, this is given to me, let that be p. I want to insert a node after p. I want to insert a node after p. So again, the operations remain same. I have to form this, I have to form this. Okay, same thing happens in double linked list also. I have to form this and form this. So almost it is same. There is no much difference. This is also order of 1, this is also order of 1. Inserting an element is just constant in both. Okay, then traversing the list to process each node. It means to print each element of the list, whether it is single or double. Traversing, if I want to print the elements of it, it is same as asking print all the elements of the linked list. Whether it is single, you have to traverse the whole list and print. Whether it is, when it is double linked list, again you have to traverse the whole list and print it. So the answer is first one. Deleting a node whose location is given is much better in double linked list because it takes constant times compared to single linked list which takes order of n times. Next. Okay, there is a lengthy code here. Let's try to analyze this. The following, again, C function, we will focus on the logic of linked list here, irrespective of the programming language, takes a single linked list of integers as parameter and rearranges the elements of the list. So the input here is the list, this elements. Okay, the function is called with the list containing the integers 1, 2, 3, 4, 5, 6, 7. What will be the contents of the list after the function execution completes? Okay, so some linked list code, rearrange code is given. So, and there is a linked list like this, because single linked list I am drawing it like this: 3, 4, 5, 6, 7 and null. So let us know that this head is given, that list is given means head is given as input. Head is given as input. So they are doing some set of operations. Based on these operations, what will be the list? After doing these operations, how will the list change? How will the list change into? So for that, let us go through the logic. Okay, so head node is given. For shortcut, I will take it as h. Let this be h. So they are creating two pointers pq. So there are two pointers pq. Okay, p and q pointers exist. Into temp, some integer value temp into t is there. If not list, is the list empty? No. If not list next, is the it means is it the last node? Is it the last node? No. Then, because since it is not the last node, right? Since it is not the last node, then return. If that is the last node, return. Otherwise, p equal to list. So it means it is same as writing p equal to head, because list means head here. Q equal to list next. List next means this 2. So p is at 1, q is equal to 2. So we have a p here and we are having q here. Okay. So p and h are pointing to 1, q is pointing to 2. Q is pointing to 2. So now while q is q null, q is not null. Q contains value 2, it is not null. Q contains 2, it is not null. Then temp equal to p value. P value. So I am creating a temporary variable t. Okay. So this t equal to p value. What is p's value? 1. So temp becomes 1 this time. Next, p value equal to q value. So p value equal to q value. See here very clearly. What is q value? 2. That where am I putting? I am putting in p value. So I am modifying the list. The list is becoming 2 here. Okay. This became 2, 2, 3, 4, 5, 6, 7. Next, q value equal to temp. Q value equal to temp. It is like swapping of numbers. So this value will change to 1 now. Okay, so we had this as our P. So this is how the list has changed. Then P equal to Q next. P equal to Q next. So Q next means 3. This I am making as my P now. So P has gone from here to here. Q equal to again. See, this is a ternary operator. I think you are aware of this ternary operator. If A greater than B, question mark A colon B, like this we write now. So there is a ternary operator. What is the Q value? Q equal to P. Okay, P or P next, otherwise 0. It means if Q is the pointing to null, if Q is pointing to null, then it is simply this says that if P is P null, no, then it means P next. It means P next, right? So this will be my Q. This will be my Q. P next means that is 4. So my Q has gone here from this. Okay. See, only in the condition part there is only P. Is P null? No. Then P next is the answer. If P was null, Q would have been 0. That is null pointer. Okay, 0. So now what we have to do? Again, let us repeat. So this operation is over. It will go back to the while loop. While Q is Q null? No. Then temp equal to P value. What is P value? P value is 3. So temp becomes 3. Again, it is kind of swapping only. Then P value equal to Q value. So this becomes 3. Sorry, this becomes 4. This becomes 4. And Q value equal to temp. This becomes 3. Right. It is almost again a swapping logic only. It is again a swapping logic. Then P equal to Q next. So this is I am making as my P next. Q equal to P. Is P null? No. Then this becomes your Q. Now what I have to do? Again, go back to while Q. Is Q null? No. Then temp equal to P value. Again, it is in swapping. I will just swap this. This becomes 6 and this becomes 5. Okay. Next, this is iteration is over. P equal to Q next. So 7 becomes my P. 7 becomes my P. Q equal to P. Is P null? No. Then P next. So this becomes my Q. This becomes my Q. So while Q is Q null now? Yes. Q null means it will stop the process. So tell me what is the content of the list after the function completes the execution. After function completes the execution, if you see, it is 2, 1, 4, 3, 6, 5, 7. Okay, it is again simple as that. We are just swapping two elements like this, these two and these two. Since it is an odd number of elements are there in the list, the last element remains same. Okay, so we have swapped a list like this 1, 2, 3, 4, 5, 6, 7. So we are just swapping these two. That's it. So this is again a previous question on. I hope this is clear. I hope you understood what we are trying to do here. Let's see another question. Yes. So please see this. Yes. So a function is given to us again. So we will explore this again single linked list because there is only data and one item. Single linked list question. For the given linked list P, the function f returns 1 if and only if. When will this function return f? This function f will return 1. So when can it return 1? Let us analyze the case. So there are some conditions given here. So if I put here P is equal to null or P next is equal to null or this again one more bracket, P data greater than or equal to, P data less than or equal to P next data, and f of P next, function of P next, this full is closed and this full is closed. Okay. So when will this return 1? Let us analyze the options. When will this return 1? Okay. So the list is empty or has exactly one element. Suppose the list was empty. If the list was empty, P means again head pointer. No, head is given to us. P means head. head is given to us. Okay. If the list was empty, this would satisfy, or P next equal to null. Again, since it is or, this is true means this entire expression is true, or this I came to know true, or P next P data greater than less than or equal to P next data, P data less than or equal to P next data. Will this work when there is the list is empty? No, this will not execute because the list is empty, right. So, even if it has one element, this P next data will not come into picture, it will throw error because the pointer which you are trying to access does not exist. Okay. So, that we will this will not happen. Let us say that the elements in the list are sorted in non-decreasing order of data value. So, something like this, if I have maybe 3 elements I will take, if I have a list like this 3, 2, 1, is it null? No. Is it null? No. Okay, this we ignore. Okay, or here there is AND operator. P's data, that is this is P, its data 3 less than or equal to P next data. Okay, P next data, that is 2. It is increasing non-decreasing order. Sorry, it means increasing order. No, sorry, I wrote wrong here. It should be 1, 2, 3. Like this. So, P value is 1, 1 is less than or equal to 2, true, and f of P next, f of P next means you are no calling recursion again. So, you are sending this 2 as the input. Again you check, is 2 less than or equal to 3? Yes. Again call P next until it is null. So, this is satisfied. Okay, this is satisfied, right. So, the elements in the list are sorted in non-decreasing order of data value. If the list is like this 1, 2, 3, this will give me true. Whether this is true or false does not matter, the second expression is giving true. So, in OR, when one value is true, definitely we have to check for second value also, right. So, this will give me true as the answer. This is satisfying when the list is non-decreasing order. Yeah, before no we